In this video, we're gonna see the application of the maxima and minima of two variable functions. So the first example is a candy company produces two types of candy A and B, for which the average cost of production are constant at $2 and $3 per pound, respectively. And you have QA and QB is gonna be the quantity for the candy A and candy B respectively is given by QA equal to 400 times PB minus PA and QB equal to 400 times 9 plus PA minus 2 PB, where PA and PB are the selling prices of the candy A and B. Okay, so we like to determine the selling price so that will maximize the company profit. So in this case, the variable for our function turned out to be PA and PB that we like to know the value in order to maximize the profit. So in this case, you're gonna construct the profit function. The profit function in this case is gonna be the profit of A per pound. So it's gonna be, so you see that it's gonna be the profit P. So the first step will be I'm gonna construct the profit function. Okay, so for this one, you're gonna have the profit of per pound of A. So the profit P will consist of the profit per pound of A multiplied with, okay, so it's gonna be, let me erase this one a little bit. So it's gonna be profit per pound of A multiplied with the quantity that you sold A, okay? So it's gonna be QA, okay? And it's gonna be the profit per pound of B multiplied with the number of the unit or the number of the candy or the number of pound of the candy sold for B. So the profit turned out to be the price subtract by the cost function. And you see that the cost function turned out to be $2 and $3 respectively. So the profit per pound of A is going to be the price of A subtract by the cost function 2. Okay, so that is going to give you the profit per pound, and this guy going to multiply with QA plus the price of B minus 3, and it's going to be multiplied with QB. So this one will give you the profit function. So you're gonna plug everything in this case. So this one is gonna be PA minus 2. Okay, multiply with QB, so it's gonna be 400 PB minus PA. Okay, so it's gonna be PB minus PA. And you're gonna plus by PB minus 3, and you have 400, 9 plus PA minus 2 PB. Okay, so this one will be your function. So it's gonna be invariable PA and invariable PB. So we like to maximize this guy. So we need to proceed by finding the critical point of this function. So it's going to be, you'd like to know PA and PB that is going to be maximize your profit. Okay, so in this case, you're gonna differentiate this guy with respect to PA and differentiate this guy with respect to PB. Okay, so let me just check whether I get the correct function. Yeah, everything is correct. It seems long, however, it's not that difficult to differentiate. So this one, after you have the function, you're gonna proceed by finding the derivative with respect to PA and derivative with respect to PB. Okay. So in this case, in order to obtain the derivative with respect to PA, so you will need to use the product rule for the first one, and you use this one, so it's going to be dPA, dP by dPA. So dP by dPA, so the first guy here, you need to use the product rule. So it's going to be the first derivative of the second, but plus the second derivative of the first. However, one thing that I can pull out is going to be the constant 400. And you see that after you pull out 400, it's not going to be hard to differentiate anymore. So you see, I will pull out 400 first. Okay, and then I'm gonna have the first derivative of the second, PA minus 2, derivative of the second is -1, okay, plus the second derivative of the first, so it's gonna be PB minus PA, derivative of the first is 1. So this one is the derivative of the first term, and derivative of the second term turned out to be you don't need to use the product rule, so it's going to be PB minus 3, and you differentiate the function here, so it's going to give you 1. Okay, so this one will be your derivative. Okay, so it's going to be just like that. And you see this one. Okay, so you see this one that is going to turn out to be 400. So it's going to be 400, and you see that it's going to be inside, it's going to be negative PA plus 2, okay, and it's going to be plus PB minus PA, okay, plus PB minus 3. Okay, so this one, okay, so it's gonna be like that, and this guy will turn out to be 400 multiplied with how much do I have? Negative 2 PA, okay, plus 2 PB, okay, and you're gonna see minus 1, okay. So this one will be dP by dPA, okay, a little bit messy. And you have dP by dPB. For this one, you're gonna do the same thing. So you have 400 outside. Okay, and then for the first term, you don't have PB, so it's going to be PA minus 2. Okay, so it's going to be PA minus 2, and you're going to have the derivative of the second term, so it's going to be the first derivative of the second, which will be negative 2, plus the second, so it's going to be 9 plus PA minus 2 PB, derivative of the first, which is turned out to be 1. Okay, so it's going to be this one, and you simplify this one, so it's 400 PA minus 2, and you have minus 2 PB plus 6 plus 9 plus PA minus 2 PB. Okay, And you see that this one will be 2PA, okay? So it would give you 400, and it's gonna be 2PA, and you're gonna have minus 4PB, okay? And you have 7, not 7, 13, okay? So this one will be the second, not the second, so it's gonna be dp by dpb, okay? And then you gonna solve for critical point, so you're gonna let this guy equal to 0, and you gonna solve for the critical point. So you have your first equation, second equation, and you're gonna have 1 plus 2, right? So you have 1 plus 2. So 1 plus 2 allow you to get negative 2PB, okay? So this one you can get rid of 400, okay? So and divide by 400. So in this case, so you're gonna get negative 2PB equal to, so you plus, so it's gonna be plus 12 equal to 0. This will give you PB. So 2PB equal to 12. So you get PB equal to 6. Okay, so you have PB equal to 6. So after you have PB equal to 6, you just plug into A or plug into 1 or plug into 2. So you put in the second one or you put in the first one, it doesn't matter. So you're gonna get negative, okay? So it's gonna be 2PA minus 4 times 6 plus 13 equal to 0. So you get 2PA equal to 24 plus 13. So it's going to be 11, right? So it's going to be 11. So you have PA equal to 5.5. Okay. So you have the critical number is 5.56. Okay, is the critical point. Okay, so this one will be your critical point. And then you're gonna have to find the second derivative. Okay, when you find second derivative, be careful that you still have 400. When you like to find second derivative, you're gonna use this term and this term. Okay, so let's find the second step. So for the second step, you're gonna find pxx, pxy, and pyy. Pxx turned out to be pxx, so you differentiate. I'm gonna have to say PAA, right? Let's say PAA, okay? PAA in this case is gonna be negative 800. PBB is gonna be negative 1600, and PAB is gonna be 800. Okay, so you would get D equal to negative 800, negative 1600 minus 800 square. And this guy, you gonna get something positive. I don't care about number, I just care about the sign. So you see that this guy is more than 800 square anyway, so you have D positive. So you have D positive and you have PAA equal to negative 800, which is negative. So the conclusion here is going to be 5.5 and 6 turned out to be relative maximum. Okay, so you have relative maximum with maximum profit equal to, okay, P at 5.5 and 6. Okay, so you're gonna plug in to the original function and give me the number here. Okay, so please do this one by yourself. So this one, okay, so it's going to be maximum profit equal to the number that you plug in, PA equal to 5.5 and PB equal to 6, okay, into the function. Okay, so that will be our first example. Okay, you see it's kind of long question. The second one, you see that for product A and B, the joint cost function for a manufacturer is C equal to 1.5 QA square plus 4.5 QB square. And the demand functions are PA equal to 36 minus QA square and PB equal to 30 minus QB square. Okay, so we like to find the level of production that maximizes the profit. Okay, so in this case, again, we have the demand function. So the demand function will imply the revenue function. Okay, so let me write down here. So you have this one, the revenue. The revenue is going to be the price multiplied with the quantity that you can sell, PB, QB in this case. And then this one will be just 36 minus QA square, okay, multiply with QA plus 30 minus QB square multiply with QB. Okay, so this one will give you the revenue, and the profit turned out to be the revenue subtract by the cost. Okay, and then you're gonna just give me this number, so it's gonna be 36 QA, okay, minus QA to the third plus 30 QB minus QB to the third. Okay, so it's going to be 36 QA, and you subtract by the cost function. So you're gonna minus 1.5 QA square, and you're gonna minus 4.5 QB square. Okay, so this one will give you the profit function. After you know the profit function, you're gonna find derivative with respect to QA and with respect to QB for the critical number. So you have derivative for P with respect to QA. Okay, so you see that it's gonna turn out to be 36 minus 3QA square minus 1.5, so it's going to be 3QA equal to 0. And you have dP dQB equal to, okay, so for this one, you get what? You get 30, okay, QB, so it's going to be 30 and minus 3QB square, and you have minus 9 QB equal to 0. Okay, so they are correct. Yeah. And then I'm gonna have to solve for QA and QB. So in this case, you would get QA square, okay, minus, so it's gonna be plus QA, and you have minus 12 equal to 0. So you factor this one, so you would get QA minus 4, QA plus 4 minus 3 equal to 0 in this case. So you're going to have QA equal to negative 4 and 3. Okay, so you're going to have QA equal to negative 4 and 3. And you're gonna have QB in the same way. So it's gonna be QB squared plus 3QB minus 10 equal to 0. That allows you to factor with QB, you have 5 and you have 2. So it's going to be plus 5 minus 2 equal to 0. So you get QB equal to negative 5 and 2. Okay, so the quantity cannot be negative. So this one, number 4, okay, negative 4 and negative 5 cannot be included in the critical point. So we have only one critical point. So it's going to be 3, 2 is the critical point. Okay, so you have only one critical point in this case. The next one, you're gonna find the derivative with respect to QA, QB. Okay, so you need PAA. Okay, so for PAA, you're gonna take a look here and here. Okay, so you're gonna have PAA. So when you find derivative with respect to QA, it's gonna turn out to be negative 6 QA minus 3. And PBB is gonna be negative 6 QB minus 9. Okay, and you have PAB, which turned out to be 0. Okay, so you're gonna have D equal to PAA. Okay, so it's gonna be PAA PBB minus PAB square. So in this case, it's going to be negative 6 QA minus 3, negative 6 QB minus 9. Okay, and you're gonna put QA equal to 3 and QB equal to 2. Okay, so D at 3, 2 will be what? Will be negative 6 times 3 minus 3 multiplied by negative 6 times 2 minus 9. Okay, and you see that this guy is positive. I don't care about number. I know that it's negative times negative is gonna be positive. And you have PAA at 3, 2 turn out to be negative 6 times 3 minus 3, which is negative. So you have 3, 2 is a relative maximum. Okay, so by the second derivative test, you have 3, 2 is a relative maximum with the maximum profit equal to, okay, so it's going to be maximum profit equal to P at 3, 2, okay, and you just plug in QA equal to 3, Q2 equal to 2, okay, and you find the profit for me in dollars. Okay, so that you can do by calculator. Okay, so for this one, you see that we construct the revenue function and the profit turned out to be revenue subtract by the cost function, and you maximize the profit by using the second derivative test by finding the critical point, and then you test the critical point for relative maximum, you compute D and you compute PAA. Okay. The next one is again the profit. A company manufacture, okay, and sell two product called item 1 and item 2 and sell for $10 and $9 respectively. Okay, the cost of producing X unit of product 1 and Y unit of product 2 turn out to be this 400 plus 2XY something. Okay, so we like to find the value of X and Y that maximize the company profit. So you see that this one gives you sale for, okay, so you would get the revenue. Okay, so you would get the revenue equal to 10x plus 9y. Okay, and you would construct the profit function. Turn out to be the revenue subtract by the cost function. Okay, and the cost function is given by the 400 something. Okay, so this one is the cost function and the revenue is the yellow guy. Okay, and then you're gonna find the maximum profit. So this one will be your assignment. Okay, so I will give you this one as an assignment for this week. Okay, so you turn this one in together with other assignment that you will have. Okay, so I introduce you a little bit here and you can continue from here. Okay, the next one, we like to find the dimension of the rectangular box of least surface area. Okay, so the keyword here is going to be least surface area that has the volume equal to 125 cubic inches. So first of all, the question asks you to construct a rectangular box. So the rectangular box will be the box that you have like the width, the length, and the height. So for this one, you get something like this. Okay, so let me draw a box for you. So for this one, it's going to be here. Okay, so it's going to be rectangular box. So you have X. So you have X, you have Y. Okay, and you have Z. So let me use in a regular way. So it's going to be you have X, Y, and Z. Okay, so you have X, you have Y. Okay, with its width, and the Z is here. Okay, and you have the rectangular box that has the volume equal to, so the volume in this case equal to 125, and it's not gonna say open top, so it's gonna be, you're gonna have the top and the bottom. So for this one, you see this one and you see this one. Okay, and you see the bottom here. Okay, so you see the bottom and the top, and you see four sides. So you see the volume equal to x times y times z, x times y times z. Okay, and you have the surface area. The surface area turned out to be, you see that you're gonna have two sides that opposite. Okay, so this one is the blue one that opposite. Okay, so the red guy will be XZ, the blue guy turn out to be YZ, and the green guy turn out to be XY. Okay, so this one will be like a surface area. However, you're gonna have to double this guy. Okay, so it's gonna be left and right, and top and bottom. So you're gonna have to double it. Okay, and from here you're gonna have that equal to 125 over xy. Okay, so this one will be the thing that you have, and you see that you have z equal to 125 over xy, and this one will be z, this one will be z, and you're gonna plug everything in. So you have a xy will be given by what? Will be given by 2, okay? And you have xz, so it's gonna be x times 125 xy plus, okay, yz is gonna be y 125 xy, okay? And you plus xy. So this guy will be 2, and you have 125 y, and here you get 125 over x, okay, and you plus xy. Okay, so this will be the function that you have, okay, for axy, and you like to find the minimum for the surface area. So you need to minimize this guy. Okay, so you need to minimize this guy. So you're gonna find ax and ay. Okay, so you need the partial derivative with respect to x and partial derivative with respect to y, and you're gonna continue by, you're gonna find axx, okay, axy and ayy, okay, yy and axy, in order to test for relative minimum in this case. Okay, so for this one again, I will give you for the assignment first, and I will continue lecturing you in class. Okay, so for this one, I allow you to do it on your own for your assignment. You have to find the critical number, and you're gonna have to test the critical number for me in order to conclude that you're gonna get the relative minimum, and you're gonna be able to have the surface area. I will continue this one in the recitation that we're gonna have this Thursday. Okay, so you're gonna have to work on this assignment by yourself a little bit. So this one will be again that the thing that you have to hand them in. Okay, so that is for this section, and it's gonna be that is gonna be the thing that we're gonna have for this clip. Okay, thank you.